All right, well, welcome back to another video. So at this point, you know what equations are, you know how to solve some basic equations, and you know what linear equations are, but I haven't really taught you how to solve them yet. So that's what this video is going to start that. We're going to break this up in about 3 videos, some different techniques for some different situations. So we're going to talk about how to solve some linear equations when you have to distribute and maybe combine some like terms. We'll start slow. We'll get some pretty nasty stuff by the end of this video. It's going to go quick, but we're going to spend some time explaining what this is on some of these examples. So the first thing I want you to do whenever you're solving any linear equation, it has one variable raised to the first power. The first thing is look on both sides of your equation, simplify both sides. Now that means a couple things. That means that you might have to distribute. Distribute is when you have your parentheses and you multiply through one term by several terms inside. Multiply each one, that's called distribution, removes parentheses. That's the idea, opposite of factoring. Next, if you've distributed, you might have to combine some like terms. Like terms, the definition of that, what we need to know about like terms. Like terms are the same terms having the same variable raised to the same power. So for us, since we only have one variable raised to the first power, your like terms either have a variable or the like terms don't. So basically that means terms with variables, you get to add those. Or terms without variables, constants, you get to combine those as well. So that's basically it. So we'll be talking about combining like terms in this video. The third thing, probably the most important when we get to it next video, is you need to know how to kill fractions, how to get rid of fractions in an equation. I can do that? Yeah, that's awesome. That's the best thing about equations, is I'm going to teach you how to destroy fractions, get rid of fractions in any equation, and get rid of decimals, because decimals really are just a fraction. So that's step number 1. Simplify both sides of your equation. I'll show you that in a little bit. I just want to walk through these first. After that, you're going to be left with at most 2 terms on each side of your equal sign. Variable constant equals variable with a constant. That's it. You can have at most 4 terms total, period, after you've simplified both sides. Here's how to go through the process of solving those equations. Number 1, if you have 4 terms, 2 on each side, you'll have a variable on each side of your equation. One of those variables will look smaller. What I mean is literal smaller, like positive numbers are bigger than negatives here, no matter what. -7 would be smaller than -2. Both of those would be smaller than 5. That sort of smaller. I want you to get rid of your smaller variable. And the only way to get rid of it entirely would be to add or subtract. You see, if you multiply or divide, you're going to get ones. I don't want you to do that. I don't want ones. I want the zeros here. I want you to completely remove these terms. So we're simplifying both sides. That's distribution. That's combining some like terms. That's getting rid of fractions and decimals. That means you have at most time you don't have this, but 2 terms on one side, variable added or subtracted to a constant, and then other side, variable with a constant. That's it. Get rid of the smaller variable by adding, subtracting. After that, you'll have at most 3 terms. You'll have a variable with a constant on one side and just a number on the other side. You would have removed one of the variables. Working on the variable side, you're going to eliminate the constant next to that variable. This can only be done by addition subtraction. You see that constant is attached to your variable by addition subtraction. Add or subtract. That will remove that constant term from the side of the equation that your variable's on. After that, you got 2 terms. You'll have a variable equals constant. Get rid of the number in front of your variable. That's called a coefficient. And because that number's in front of your variable, right next to it, it's connected by multiplication. The only thing that undoes multiplication is division. That's why that's always our last step. So you can hear me say this a lot. Your last step, always division. In solving linear equations, you'll always be dividing last, because the number that's in front of your variable always gets removed last, and it's always connected by multiplication. That's what coefficients are, and you always remove that by division. You don't even have to worry about multiplication here, because I'll teach you how to kill fractions in another video. So let's get started. These are our steps. I wanted to walk through them one time. I know right now they're like, I don't know how to do those yet. Yeah, I get it. Don't worry about that. We're going to do that right now. So we're going to start simple. We're going to start with some linear equations. So first off, you need to be able to verify this. Is that a linear equation? You should be like, yeah, for sure. Why? Why is it a linear equation? And right now, pop in your head should be, well, there's an equal sign, and I have one variable, it's raised to the first power, we're good to go. That's a linear equation. Actually, it's in the ax plus b form also. Your a would be, think about it, your a would be 9, and your b should be not 8, but -8. Can you solve it? Well, let's go through these steps because this should be how to solve any linear equation like ever. Firstly, simplify both sides. Here's what you're looking for. Both sides, what that means is when you look at the sides of your equation, you look at the left side and you ask yourself these questions. Do you have any parentheses? Because if you do, you got to distribute. Do you have any fractions? Because if you do, you'd be killing fractions right now. Do you have any like terms? Now this is important. Like terms, please do not miss this. Like terms can only be terms on the same side of an equation, same side, that you can combine. So that means they both have a variable or they both don't. One term can't have a variable and the other term I say first can't have a variable, and the other one does have a variable. Anyway, you can't mix them up. The terms that you're combining, like terms, they gotta both have variables or both not have variables. Specifically, like terms are terms that have the same exact variable raised to the same exact power. Since we're only dealing with linear, they'll all have a power 1 for us. Otherwise, they're not like terms. So when we look at this, we ignore the right side. We look just here. Are these like terms? Well, the answer to that question is, do they both have variables or do they both not have variables? Since one has a variable and the other doesn't have a variable, that screws our definition of like terms all up. You see, we can't have the same variable raised to the same power if one of our terms doesn't have a variable. You can only combine like terms. So since we don't have two terms with the same exact variable, we're done. That's simplified. Well, that's good news. We have nothing to distribute. There's no parentheses. We have no fractions, that's great. We have no like terms, so there's nothing to combine. The left side's completely simplified. The right side, well, there's only one term there. That's automatically simplified, so we're good. Step 1 is accomplished. We've simplified both sides. Now the next step. The next step is kind of an if step. If you have two variables, get rid of the smaller one. Well, look at it. Do we have two variables here? If you did, right now hopefully this makes sense to you, okay? If you had two variables at this point, they have to be on different sides of your equation. Because if they were on the same side, you would have combined them in step 1. That's called simplification. That's combined like terms. So if you would have two variables over here, you'd be combining them in linear equations. We don't have that. And now the second step, if you had two variables at this point after step 1, they'd be on different sides. You'd have to get rid of the smaller one. We don't have that. So step 2 is accomplished also. We don't have two variables, so there can't be a smaller one. Now, step 3. This is where we're at in this particular problem. We've simplified both sides. We've got rid of the smaller variable. There's only one. Can't do that. Now we get rid of the constant term. So what the constant term is when we're talking about the constant term is a term without a variable. Now, will there always be a constant term? Not always, but if you combine like terms and you still have two terms, there's going to be a constant term. How you get rid of that term goes back to what you learned right in the introduction to solving linear equations, or solving equations at all. How would you get rid of the term without a variable here? Well, look how it's connected. How is this connected to your first term? Well, it's connected by minus 8. Now all this stuff pops in our head. How do I get rid of minus 8? Plus 8, let's do that. What I do to one side, we have to do to the other side. So we've simplified both sides. Cool, it's already done. We combined some like terms, that's part of simplification. We looked for two variables. We don't have two variables, we just have one. We get rid of our constant term first. You see, you have a choice, but only one's the right choice. You could start dividing by 9, but then you'd have to divide this by 9 also. That gives you a nasty fraction right off the bat. I don't want to do that. So we choose in solving linear equations to eliminate the constant term first by addition or subtraction, because that's how a constant term is always going to be connected. Otherwise, it wouldn't be a constant, it'd be part of the coefficient. So we get rid of our constant term because it's connected by addition subtraction. We use either addition or subtraction to undo it. What we do to one side, we do to the other. Let's look here. Remember when we started talking about addition subtraction, you wanted to get zeros? Does that still work? Can I take minus 8 plus 8 and get 0? Well, yeah, that's great. And 9x plus a big fat 0 still leaves you with 9x. Awesome. We still have our equal sign. Now we take 0 plus 8. Hey, 0 plus 8 is 8. Now this leaves us with our just one last thing. Remember what I told you? If you simplify, after you simplify, you're going to have the most 4 terms, 2 on each side. After you get rid of your constant term, you're going to have at most 2 terms, 1 on each side. As a matter of fact, one of those terms is going to have a variable in it, and one of them is not. Otherwise, you would have combined them. So we got one variable, we got one term on the other side that's a constant term. The last step is getting rid of the number in front of your variable. In this case, it's x. We call that a coefficient. So a coefficient, all it really stands for is the number being multiplied by your variable. That's it. That's all you got to know. So how you get rid of the number, oh man, it's even in how we said that. How you get rid of the number being multiplied by your variable? What undoes multiplication? Remember what we're trying to get here. We're trying to get, well, with addition, subtraction, zeros. Because when you add or subtract 0, it doesn't change your first term. You keep your first term. When you're dividing or multiplying, you're trying to get 1. Because when you multiply or divide by 1, it doesn't change your variable. That's what we're trying to do, is trying to get rid of pieces without changing all the rest of our pieces. Trying to get rid of terms without changing all the rest of our terms, or coefficients without changing all the rest of our terms. So how we get rid of our 9, hey, if we have 9 times x, the inverse of 9 times is dividing by 9. You just have to show your work. You have to show both sides. Hey, what's 9 divided by 9? You get a big fat 1, really. 1 times x leaves us with our x. That's exactly what we want. We want to isolate our variable. Get it all by itself on one side, nothing else around it. Oh, nasty. Can you end with a fraction? Is that okay? How about 8/9? Is that a simplified fraction? Look at it. Can you divide 8 or 9 by the same number besides 1? Then you're good. Leave it as a fraction. That's okay. Now, it's kind of hard because, yes, you can check your work, but now you're dealing with fractions. How you check your work with fractions is the same as checking work in any other equation. You just plug it in. I'd recommend a calculator, though. So if you plug in 8/9, use your fraction button. 9 times 8/9 equals, it's going to be 8. Minus 8 equals 0. So we know for sure that that's a correct solution. That's the only solution. Linear equation has exactly one solution, or no solutions, or infinite solutions. This is our one solution. I'm hoping that makes sense to you. Walk through these steps one more time. If it takes you pausing the video and looking through, like, well, what are we really doing here? We're checking for this. We're checking for this. Then we didn't have it. We eliminated our constant first. That's an addition or subtraction move. Lastly, we divide. Your last step's always going to be division. Let's do another one. Now, some of you might be thinking, how do I even tell if that's linear? How can I see a linear equation out of that? Well, do you have one variable? Is it in an equation? Do you see an equal sign? Yeah, sure. Is that one variable be raised to the first power? Yeah, it's still a linear equation. Now the question becomes, what in the world do we do with it? Do we start willy-nilly adding, subtracting? No, that's why we get steps. That's a really bad idea because we go down this rabbit hole that a lot of times we never get out of it. We get really lost really quickly. So step number 1, let's look at both sides and let's simplify them. What that means, if you have parentheses, you're going to have to distribute. Get rid of the parentheses first. There's no way to add or subtract to both sides when you have parentheses up there holding stuff together in this case. So we're going to look at the right-hand side first. Can you simplify the 21? That's one number. There's nothing to add to it over there. We're done. Can you simplify the left-hand side with the parentheses? If you're not familiar with distribution, that'd be a pre-algebra thing. That's okay. You can go look at the video right now. I talk a lot about distribution in that video. What distribution means is kind of like playing cards. If you were to deal out cards to a table of friends, you'd give every person a card. That's kind of what we're doing here. We're giving every person, except person becomes term and deal becomes multiply. We're taking this number outside the parentheses right next to it, and hey, look, that does mean multiplication. 3 next to parentheses means 3 times whatever's inside of it. we're going to do that. We're going to take 3 and multiply by whatever's inside of it. That becomes 3 times 2x times 2x, well, that's 6x. And then 3 times positive 5. Yeah, we're going to use that plus kind of as a positive. We're going to think positive because of the way these rules with signs work. So 3 times positive 5 gives us positive 15. You say positive, you write plus. We're kind of tricking the problem here to our benefit. When you use your signs that way, you can kind of shortcut a lot of work. So when we do positive 3 times positive 2x, yeah, we get positive 6x. When we do positive 3 times positive 5, we get positive 15. Just write plus 15. Yeah, I know this is a plus and you're saying positive, but for those reasons I explained, like the subtraction where you can write minus as plus and negative, we can use those signs to our advantage. Now on the right-hand side, we weren't able to do anything. So we just get 21. Now I'm going to ask you a question here. I want you to think about it before you go on with the video. Do I have any like terms? Really think about that right now. So I'm still on step 1. I'm trying to simplify. I've just distributed. Do I have any like terms? Like terms must be on the same side of an equal sign. They can't be on opposite sides. So when I ask you for like terms, it's really this question. Please don't skip over this, don't ignore this, just focus here for a second, okay? You've got to get this. When I'm asking whether he's got like terms or not, I'm asking for this. Cover this up, look right here. Are these two terms like terms? They both of them don't have variables. One's got a variable, one doesn't. These are not like terms. Okay, stop. Now look at this side. Does this side have any like terms? There's only one term. They can't be like terms. That's answering that question. So when I say combine like terms, what I mean is a side-by-side approach. So you look here, if these two aren't like terms, there's no like terms here. If there's no like terms here, you have no like terms in the problem. A lot of students get really confused and go, well, those are like terms because they're both constants. They both don't have a variable. Those like terms. If they were on the same side, yes. If they're on opposite sides, no. Like terms are an expression idea, not an equation idea. Expressions are on one side or the other side. So there's no like terms in this problem. Those aren't like terms. There's no like terms here. No like terms exist. So we're done with step 1. We've distributed. There are no like terms. There are no fractions. Now we go to check step 2. Step 2, we look for if this has 2 variables. Right now, well, we don't. We just have 1 variable. That's great. Step 2, we're done with step 2. Now we go on to step 3. In step 3, we're going to look at this and we're going to eliminate the constant. Now, if you're thinking, well, wait a second, there's a constant here and there's a constant there. What constant are you talking about? Remember your goal. Remembering your goal will answer that question. You are always trying to isolate your variable. You're trying to get your variable by itself, which means that you're trying to get everything away from that. That's the side that drives your problem. So we're looking just at this side. I didn't care what that is right now. I didn't care about 21. I care about getting the x by itself. So honestly, you could just completely cover this up and you could tell me exactly what to do on this step. Right now, in the interest of getting the variable by itself, the variable of x, with your pencil on it, you're going to eliminate the constant first. That's an addition-subtraction move. So right now, you're undoing plus 15. That's what step 3 is telling us. So when we get rid of our constant, we're going to be subtracting 15. I don't even care what the 21 is. I'm subtracting 15 from it. On the left-hand side, look what it does. It gets us one step closer to getting that x by itself. 6x plus 15 minus 15, hey, that's 6x plus 0. Remember, we're trying to get zeros with addition and subtraction. 6x plus 0 gives us back 6x. Right-hand side, 21 minus 15. Man, we can do that. That's just going to be 6. So we distributed. We didn't have any like terms, not like terms. Different sides, not like terms. We tried to combine like terms. We didn't do it. We couldn't do it. We have only one variable. Let's get rid of our constant by addition and subtraction. And the last step, at the last step, you should have at most 2 terms. One on each side, one with a variable and one without it. Get rid of your coefficient, that number in front of your variable, by, got to be division. Since it's connected by multiplication, you've got to have division to undo that. This kind of looks familiar, doesn't it? It looks like we've done this before. That's how this started. 6 divided by 6 gives us 1. Hey, we're trying to get 1s with multiplication and division. 1 times x gives us back our x. Now that's a little weird. What's 6 divided by 6? Is that okay? Sure, just get 1. You know what? You can actually try it. Check this out with me. Plug in the 1. Remember, order of operations tells us to plug this in, do our parentheses first. 2 times 1 is 2. 2 plus 5 is 7. Then 7 times 3 gives us 21. We always plug it into where we start our equations. But we know for sure that our only solution here, our only exactly one solution is going to be 1. I'm going to do 2 more with you. And then what I'm going to do is I'm going to put, well, I'll probably do three with you. And I'll put 3 on the board. And I want you to work on them. And so, of course, I'll be going right to it. But I'd like you to pause it and try on your own after these next 2 examples. Okay, we're going to start not picking up the speed, but I'm going to stop explaining everything about all the previous stuff that I've spoken about. I mean, it's already kind of should be getting in your head at this point. So let's look at the example real careful. Is it an equation? Clearly. Is it a linear equation? If you're thinking, well, look, there's 2 variables. What linear equations mean is the same variable. We have that. They're all x's. Raised to the first power. We have that too. They're all raised to the first power. That's still a linear equation because you have one variable. Yeah, there's a couple places, but it's raised to the first power. Now, answer this question for yourself. Do you have to simplify it? Well, this side, no, you're good. Totally good. This side, heck yeah. Now, when you say you got fract, well, you got parentheses, you're going to have to distribute this. You're absolutely right, but let's be real careful what we're distributing. If you're going to distribute, it's not just 3. I always tell my students, and you're my students now, so I always tell my students, circle the number in front of your parentheses with the sign, because that's the number that's going to distribute. Some of you might be at this level of class because you messed up that sign so many times. It's kind of, you practiced a bad habit so many times, you distribute 3 instead of -3 all the time. Well, if you distribute this -3, our 2x, yeah, we got to know order operations at this point. Multiplication, next parentheses, multiplication, happens before any combining like terms because that's an addition subtraction concept. Parentheses first, exponents, multiplication, division, that's where we're at. Distribution is multiplication, and then combining like terms because that's addition subtraction. So let's drop down our 2x. If we distribute our -3, well, -3 times positive x gives you -3x. If you say negative here, use that sign, but if you say negative, you're going to write -3x. I know we're kind of cheating a little bit. We're using the negative to give us back our sign of a minus. That's okay. You see, we can do that. We can write down any negative as a plus minus. So like, we could write down 2x plus -3x, because that's what that would be, or we can revert that back to the minus. They're interchangeable. You can go either way here. So what we're doing is kind of tricking the problem by saying, hey, yeah, I know that that's a minus. You're kind of taking the minus with this as a -3, multiplying it by x, and then bringing it back down as that minus sign. So in your head, you're saying negative, but you're actually writing down a minus. The next one, -3 times +2, well, that's -6. You say negative, we're going to write minus. So we've distributed, we've taken this -3 times each of the terms in there and got 2x minus 3x minus 6 equals 9. Now, a lot of times when you distribute, you're going to have some like terms. Let's check that out. Do you have like terms? Like terms is a side-by-side approach. Do you have like terms here? Do you have like terms here? Yeah. We've got a 2x, and always circle like terms with their signs. We have a -3x. Let's add those. Combine like terms as an addition approach. How much is 2x minus 3x? You got 2 xylophones, you take away 3 xylophones. I don't know how that's possible. You'd owe a xylophone. Get your signs right. That's the biggest thing I can get you to do. Use your calculator if you have to. 2 minus 3. I don't care. But we use additional. That's fine too. But we got to get our signs right. 2x minus 3x. Circle them, cross them out. You have negative x. Now we're going to drop down our minus 6 equals 9. That's fine. But look what that does. When we combine some like terms, all of a sudden it gives us only 2 terms left here at most. If you combine like terms, I guarantee you, if you combine like terms on linear equations, you will have at most 2 terms on each side. Here we have 2 terms, here we have 1 term. Let's keep going. So we distributed, we combine like terms. We don't have 2 variables. When I say 2 variables, look what happened. Look where this is. When I say get rid of the smaller variable, that's after combine like terms. After that, what that means is that if you're getting rid of the smaller variable, 1 would be on each side of your equation. So here we don't have that. So there's no smaller variable because there's only 1 left after combining. So we jump down to step number 3. Let's get rid of your constant. Do it on your own if you can. Right now, get rid of your constant. Am I talking about the 9? Is that the constant? Or am I talking about the minus 6? Our goal is always to get that variable by itself. So I'm talking about the minus 6. You know what to do. Get rid of that minus 6. How would you get rid of the minus 6? Add, subtract, multiply, divide. Think about that. The only thing that's going to do it for us is adding 6 to both sides. Negative x minus 6 plus 6, this gives us not a 1. You're getting a 0. But negative x plus 0 is negative x. On the right-hand side, we're still adding, we're getting 15. Now, what the heck? Negative x? Is there a number in front of that x right now? We talked about coefficients as the number in front of your variable being multiplied. What you know from a long time ago is that anytime you get an x, there's always a little 1 in front of it. That goes for this also. So if you have negative x, it's really telling you that you have a negative 1x. How will we get rid of a coefficient? Bar none, no matter what. How are you going to get rid of coefficients? By dividing. So let's divide both sides. Remember with division, you're trying to get a positive 1. So with division, you're going to be divided by exactly the same number that's in front of your variable. That's how we undo multiplication. And that's how we get positive 1. Negative 1 divided by negative 1 is positive 1. Positive 1 times x, hey, gives us back x on the left-hand side and negative 15 on the right-hand side. That's the idea. We're going to do one more. Let's do one more together. I'm going to give you probably 2 to do on your own. I'll do one more, you'll do one. I know it's a longer video than some of the other ones, but it's important. This all has to be done at one time. Okay, this is huge. If you get this one and you know distribution, you're going to be good to go forever on this stuff. But I got to get you to get this one. So, linear equation, what do you think? Yes or no? Just in your head, just be like, yeah, or like, I don't know. If you don't know, that's okay. Let's think about the definition. Is it an equation? Does it have one type of variable, and everywhere you see it, it's raised to the first power? Yeah, that's a linear equation. So let's answer the next part. Can we simplify it? Can we simplify both sides? Well, here's how simplification works. It's always a side-by-side approach. So we go here, ignore the side. Don't even look here, look here. Do you have to distribute? There's no parentheses. Can you combine like terms? Listen carefully, don't miss this. Are those like terms? You can't combine like terms here. Look at this side. Do you have to distribute? Can you combine like terms? Right now, even though you have this, there are no like terms in this problem. Like terms are an expression idea. They have to be on the same side of an equation. That's an expression together with the equal sign, they make an equation, but they're not like terms. If they're on different sides of the equal sign, you have no like terms. So step 1, done. Step 2, if you've combined like terms and you still have 2 variables, one's going to be on one side and one's going to be on the other side. Get rid of the smaller one. The only way to remove it completely is by addition, subtraction, not multiplication, division. Because if we divide, we get 1. Here, we have to subtract. What I mean by smaller is literal smaller on a number line. So, like 2 is less than 5 for sure, but negative 13 would be less than 2. And negative 15 would be less than negative 13. So as we go more negative, those numbers get smaller and smaller. That's what I'm talking about here. Get rid of the smaller variable by addition subtraction. So if we want to get rid of 2x, we're going to have to subtract it. So 5x minus 2, now notice what happens. As soon as I do that to both sides, I do to one side, got to do the other, it creates like terms. Like terms are defined as being on the same side and equal side. That's kind of cool. So if I'm working on both sides, I'm using the fact that I want to get rid of this 2x by subtracting 2x. I have to have the teeter-totter keep it the same, but now these are like terms. Now I can combine like terms that are on the same side. 5x minus 2x is 3x. And as soon as you do that, folks, you're back to the stuff that you already know how to do at this point. Hopefully you've been trying this on your own. Now we get rid of a constant. Let's subtract 7. 3x plus 0 is still 3x. We created zeros when adding and subtracting. Last step is always divide. Let's get rid of our coefficient. Divide both sides by 3. Hey, 3 divided by 3 is 1. We're trying to create ones with division because 1 times our variable gives us back our variable. On the right-hand side, it's okay to end with fractions. They're just a little harder to check your work with, but we get 1/3. That's it. What I'm going to do right now is I'm going to give you a chance to work on 2 examples. I'm not going to pause, but I'm going to go through them very quickly. So I would really, really highly recommend for you to do these on your own when I put them on the board. Pause the video if you can. If not, if you just want to walk through it, that's fine too. That's all right, but I would really recommend you do them on your own. So I'm going to start right to it. We're going to go quickly because this is your guided practice. It's a good way for you guys to learn and gals to learn. If you're really in a class, you need to be practicing before your teacher goes through some examples. If they give you time to do it in class, do the work. Even if you make mistakes, it's okay. You're still learning it. That's fine. Right now is the time to kind of screw things up so that later you learn, well, you learn from it, so later you won't screw it up. So right now, we're checking this equation. First thing I'm checking for is simplification. I'm looking left side, nothing. Looking right side, nothing. Simplification should be on a side-by-side approach. I have nothing to simplify, no like terms. These are not like terms on different sides, no distribution. After that, I'm looking to see if I have 1 variable or 2 variables. If I have 2 variables at this point, they'd have to be on different sides. Right now I don't. So now I'm identifying where my 1 variable is. Well, we have that 3x, that's a 1 variable, and we're going to get rid of our constant. When we get rid of our constant, we subtract 5 from both sides, we get 3. On the right-hand side, we get 3x. Well, at this point, the last step is divide. We divide both sides by 3, and we get 1. Plug it in if you want to. 3 times 1 is 1, plus 5 is 8. The next one, I'm checking for distribution. I have none. I'm checking for like terms. I have no like terms. These are not like terms. These are not like terms, there's no like terms. Now the next part, if you try it on your own, a lot of you probably added 3y to both sides. That will work, but I'm going to encourage you to add 13y to both sides. That is the smaller variable. Negative 13 is smaller than negative 3. Think negative 3 here. The reason why, it's not wrong to add 3y to both sides, but the reason why we want to add the smaller, or get rid of the smaller variable all the time, is so that we don't have to divide by negatives. That's the only reason. So I'm going to be adding 13y to both sides so that I avoid dividing by a negative later. If you added 3y, that's okay, but notice that adding 3y would give you negative 10y here, where I'm going to get positive 10y on the other side. 0 plus 2 is 2, 22, negative 3y, or minus 3y plus 13y is positive 10y. I say positive, I write down plus. After that, man, we're at that step. We're exactly the same thing. Let's get rid of our constant term. We're always keeping our variable in mind here. Our variable side is what drives the problem. We're going to get negative 20. We watch our signs. If we divide both sides by 10, we get negative 2. Negative 2 equals y. That's the idea. Next time what I'm going to do, I'm going to talk about some more advanced techniques on how to solve these. So we'll talk about some advanced distributions, some advanced combined like terms, and then we'll deal with fractions and decimals. So look for that on the next video. Right now is just some basics. You should get started on this before you go any further. I don't want you to overload you right now. So I'll see you next time.